Right, okay, so stacks, super simple. Remember, stacks are amazing. It's what makes calling functions work. Interrupt handling in the CPU is only possible because we've got a stack. Okay, so one pointer, we have a stack pointer. We decrement when we're taking things out of the stack, which we call pop, and we increment when we push, when we add things. Generally you use an array type structure to hold the stack. At CPU level, the stack pointer is generally a register, and when you push them on the stack, the CPU decrements it or increments it.
I don't think the reference works too well.
No, it won't. Yeah, no, it would. You could, I mean, generally in an array, you could do it because you just use the head and access the head, so it'd be really quick. So you could do it with, we'll have a go, I'll write one. Generally an array, but you might be able to use a linked list, and we'll have a look at that then. Right, okay, so just two operations. I can't remember, what else did I say about the queue? Oh yeah, it's a last in, first out structure. You could call it a first in, last out, but don't, because that sounds like pastry. Yeah, phyllo, it just makes me think of pastry. The evil pastry, that real thin stuff with like multiple layers. Like, it's what you're, I know this is on the video again, but you know, like, what they call vanilla slices, those things, custard slices. Those things that look great, you think, oh, I'm going to enjoy that, and you take one bite and it goes everywhere. Don't eat them in company. Yeah, so call it LIFO. Right, okay, so we've got two operations, push and pop. So, they might ask you about peak. They could ask you to do it, couldn't they? Peak just doesn't alter the pointers, does it? It just looks and returns a value at the top of the stack or at a position from the top. Yeah, they might ask you to write that. But right, so let's just do push first. Obviously, you need an item. Check for stack full first. So let's just give ourselves a little example of a stack so that we don't get confused. Don't try and do it off the top of your head. Always just give yourself an example of whatever. Okay, so that's my array. Position 0, 1, 2. Then always with your arrays and your strings, do this. Put the indexes down. Say how long it is. It's going to help with everything you do in the question. Right, okay, so it's length 3. In general, I mean, in reality, stacks actually grow downwards. So this is all like the opposite way to it in reality. Right, so the stack pointer points at the free space. Okay. So when the stack is full, the stack pointer will be here. The length of the stack array. So we can do that as our test. So we can say if stack pointer equals the, and we'll call it stack.length. Remember, it doesn't matter whether you put len, stack, or dot length. It's as long as there is clear meaning that you mean the length of something. But I mean, use len or length for that. If that is the case, then it's full, stack full. Again, if they tell you to do a specific action, if the stack is full, do it. But otherwise, I'll just leave it as the logic of it. Right, okay, so if the stack isn't full, what I can do is just wherever the pointer is, so the stack pointer, which I'm calling SP, I'm just going to put my item at there, and then I'm going to increment the stack. And that's it. One of the beautiful things about the stack is it is incredibly simple to implement. yet so powerful a structure. Right, okay, so let's go for pop. Right, pop doesn't require any data, so there's no parameter. We're just going to return whatever's on top of the stack. But we've got to check to see if the stack's empty. So the condition for the stack being empty is the stack pointer is going to be pointing at the bottom location, which is 0. So we can check for 0, which is nice. Lots of ways of checking for 0 when you start implementing these things, but let's just do an if. So if stack pointer equals 0. If anyone's interested, Mural is the program I'm using, the online whiteboard. It actually writes properly, not like the ruined Microsoft Whiteboard. So Mural, you have to sign up, but you get 3 free murals, and it exports PNG of any size, which is quite good. I wish it'd do an SVG, but it doesn't. Right, anyway, right. So if it is empty, we can't pop, so that's going to be stack empty is our condition. Right, okay, if we're not empty, then we need to retrieve the item off the stack. So let's draw ourselves a stack that's got something in it, just to see if we can get the logic right. Right, so I'm going to do a few items in here, so I'm going to have X and I'm going to have T. Right, so the stack pointer is pointing at the free space. So it's one above where it needs to be. So what I'm going to do is I'm going to decrement it first. So I'm going to say SP minus minus, and then, because it's now pointing at the data item I want, so that will make the stack pointer go there. So then I'm going to say, okay, then let's return whatever's at that position. So I can just say return stack at SP. That's it. Again, they could monkey about and say the stack pointer points at the top of the stack, but that actually breaks how stacks work, so they shouldn't do that. But read the question, you might have to alter your logic. Right, let's do a think about a linked list then. Seems though you raised it, bad Cyan. Right, so that was using an array. So let's implement using a linked list or an LL. That's why I just written linked list. Right, okay, so this is interesting. So let's just set up a linked list. I'll call it stack. And let's see if the stack, if a linked list is suitable for this. I'm going to put 2 items in it because I can't be bothered to draw any more at the minute. One other thing. On some of the example questions, they've gone and used this to mean null. Right? Don't use it for null, because they've, on their own mark schemes, gone and mixed it up with 0. Which is bad when you're making a link in a linked list and you put 0, or you put that and you meant 0, because that actually would point to something. So don't use that. You've been warned. What should we use? Or null. If you've got space, put null. Then no one's going to... But yeah, -1 if you're not. Right, I'm going to put -1 because I haven't got space. Right, so let's just put some values in here. We don't know what these are. It doesn't really matter. X and K. 2 kung fu letters. If you're going to do some ASCII fighter. Which you're probably not going to do. Let's face it. Right, okay, so the top of the stack is X. So let's add a new item. Where do we add things? So if we want to push a new item onto this linked list, where would we add it? No. You've flipped the logic in your head. I'm saying the head of the linked list is the top of the stack. So if I'm going to do that, if I'm going to push, so I'm going to push to head. All right, so just to add a new item, I'm going to say, and remember that's the quickest operation you can do on a linked list. And you think, oh, this is actually quite, and I could easily traverse it if I needed to. Right, so let's say I'm going to push B. So in this case, I would create a new node, put the B in it. I'd look to see what the stack is currently pointing to, and that's the X, so that's what I'm going to point to. And then I'm just going to put that point in the main new node. Right, okay, what about pop? Pop, I want to take the last item, so the head. So all I've got to do to pop, look at what's there, and then go, where did that point to? Oh, that pointed to X, I'll point it back. So it can be done super quick. Right, well let's write the code for it then. So let's do push first. So I'm going to call it push LL. Oh, didn't put funk or anything, but it doesn't really matter. Right, so with a linked list, what's the advantage? What's the super main difference between an array and a linked list? The base difference. Yes, there are other differences than this, but this is the base thing that you should always say this about an array, and you should always say this other thing about a linked list. They're the other things. No! 2 words. One begins with S, one begins with D. Static and dynamic. Arrays are fixed, static. You decide when you create your program how big you want it to be. I mean, yes, okay, every language allows you to dynamically change the size of an array, but hey, we don't go there. But a linked list is dynamic. It can grow to any length, depending as long as you've got memory in the heap. Okay, so you don't have to decide how big you want the stack to be if you're using a linked list. So that's a positive. Always positive. Yes, the other things are array, consecutive memory locations, which mean you can use efficient processing methods. You can use clever algorithms like binary search. But we can, with linked lists, if we structure them in certain ways, we can make complex data structures like trees. So we can then do binary search. Not as efficient ever as an array, though. Bear in mind. Right, okay, so when we push something on, we don't need to check for full, do we? So actually this makes this even quicker. So we just say new node, so we can say node equals new node to show that we're generating space for it. So we might say node.value equals item. And then all we're going to do is we're going to say node.link. So obviously there's a little bit more work we're doing, but obviously you can write this in a certain way. If we created an object properly, we could create a constructor where we gave it the item and what the link was going to be. So we could do all this in one line here, but I'm just doing it in broken bits. So that is going to point to whatever the head's currently pointing to. If the head is null, it doesn't matter, because it'll put a null in for us. So I'm just going to say the head, and then I'm just going to say head equals node. Okay, so that's all I've got to do. So like I say, if I was going to be clever and create a class called node, I would create a constructor. Okay, and I could do it all in one line. I could say, so all of that could be replaced with head equals new node item comma head. So I'll pass it the link. So the head gets looked up before it gets reassigned. So we know what the current head is. Pass that on to the node. It stores it as its link. And then wherever memory location this was allocated, that head points to it. For me, that's cool. That's the power of object-oriented programming. That's more procedural. Okay. To pop, so pop linked list. I wonder if they'll ask you this. They're not. I don't think they're clever enough to come up with something like this. It's a good question, Zion. Right. So to pop it, we just need to look at what's at the head and make sure we update the head to the link of that thing. But we need to make sure head's not null. Whenever you're dealing with pointers in linked list, you've got to make sure you haven't got a null value. Because if you say null dot something, that you will cause an error. Null, as you can find in the wonderful P5JS. Null object reference everywhere. It's the main error you get, isn't it? It's really strange, especially if you, because JavaScript doesn't moan if you don't refer to something first. So, I spelt it wrong. Oh well, null reference, that's all you get. Right, so we're just going to check. So we're going to say if head is not equal to null, then what we're going to do is we're going to say item equals head dot value. Seems I used a value in this one. Okay, and then we're going to say head equals item dot link. Then we're going to return the item. So there's actually nothing complicated because you're using a linked list, but you're not actually having to manipulate the features of a linked list, really. So, note to self, think about linked list for that. Yes?
On the first line, you're treating item as a value, whereas on the second line, you're treating item as a node, I think.
Oh, yeah. So I should say,
I think item equals head.
oh, I've been yeah, right, good point. Yeah, right, okay, that was supposed to be the rubber. Oh no, I'm printing that's the colour thing. It looks like a rubber, that, I don't know. To me it looks like rubber, but I'm insane, so. Is that going to rub out? That's the only problem with this mural, it's a bit slow and they'll rub it out. Come on. I don't think it likes big. Right, you can rub it out, go on, cheers. Right, so head.link is what I should have put. So I'm just saying, whatever head's pointing to, the thing there, I want to skip that item. So just do a little diagram of that. So we've got head pointing to something, which might be -1. Let's say there was only one item in there. And all I'm saying is make head point to that thing. But yeah. So there isn't anything complicated going on there either, is there? So I mean, obviously I might put empty or something. Yeah, right, I'll stop that one there.